Hello folks, this is just a very short video to look at the end of lesson 11.14, the exponential form of a complex number. And this is a GeoGebra file which is set up to explore the investigation right at the end. So part A is sketching the points on the argand plane. We've got z equals 2e to the ti, and we're looking from 0 to pi. So we have here z1, which is this point here at the moment, and it's 2e to the ai, and we've set this from 0 to pi. So we have a's instead of t's, but yes, it's the same idea. And we can just have a quick look at what happens as we animate that. And we can see as it goes from 0 to pi, hopefully as we'd expect, as it's the argument that is changing, we are marking out a semicircle. The modulus is staying the same, so the radius of this semicircle is 2, but the argument is changing. Obviously, if we increased our domain up to 2 pi, we get a full circle. Okay, the second one, part B, says repeat for some two other complex numbers. So we've got z2, b equals bi, so we have b's instead of t's. B equals bi. So this time, the argument and the modulus are changing. So what would we expect now? If you need to, pause the video, have a quick think. What would you expect if you increase both the argument and the modulus? Let's take a look. Okay, as you see, we have a spiral that is being developed. If we'd only gone up to pi, we haven't quite got the same domain here, but if we'd only gone up to pi, our spiral would have stopped once we got to the negative real axis. I'm just going to try and get rid of this one. Okay. Yeah, so if we, let's change it to go from 0 to pi. 0 to okay, so yeah, as we said, it's going to create this spiral. Okay, the second one, or the last one here, we have, instead of just b, we have 2c. So instead of, on your worksheet, we've got t equals 2ci. And let's set the same domain. Okay, have a think. What are we expecting? How will it change from the last version? This time the argument is changing twice as quickly as before. Okay, because we've doubled the argument, we're getting one full rotation. Let's see if we have the other one as well. As you can see, the spiral is going to stay a little bit tighter at the beginning, isn't it? Okay, so interesting to see different coordinate system in action, and obviously you could create some quite interesting images using polar